Hi, my name is Visweshwar Reddy, working as an assistant professor at Mlritm. Today I am going to discussing about the operators. Okay, what is the use of operator? First, types of operators. First, let us discussing about the operators. Operators is nothing but a which help the user to give the instruction to the computer to perform the mathematical operations. Okay, normally in C, operators are classified into the 8 types that are arithmetic operators, relational operators, logical operators, conditional operators, bitwise operators, special operators. First, arithmetic operators. Here, arithmetic operators to perform the arithmetic operations like a addition, subtraction, multiplication, division, and module. Here, arithmetic operators are unary operator. Okay, that is the addition unary plus next and binary unary minus, sorry. Next one is the multiplication, division, and module operator. Here, arithmetic operators are both unary and binary operators. Okay, unary operator is nothing but it perform the operation single operand. Okay, next binary is nothing but to perform the operation both operands. Here, example for example, a plus b. This is the here performing the addition with two operands. That is the binary operations. Okay. Next, for example, unary operator means to perform the operand, single operand, to perform the operation with single operand. That is the unary operation. Okay. There are number 5 in operands. By unary, will have the value 5. That is the unary addition, subtraction, multiplication, division, and module operators. Next, arithmetic operators are here plus, minus, multiplication, division, and module. Here we take the two operands, that is the A and B. Here 15 value assigned to the A, 2 value assigned to the B. Here we are first performing the with the operation, that is the addition operation A plus B. Okay, what is the A value? A value is 15 plus 2, that value is 17. That value stored in one more operand, that is the C. Okay. Here, next A minus B, A into B, A division B, A module B. Here we are writing the one program. That is, we are writing one program by using arithmetic operators. First, here to declare the variables, that is the A, B, C. Okay. With the help of third variable, we are adding the two variables A and B. First, to read the AB values from keyboard. Okay. Next, here first to perform the addition operation, that is a C equal to A plus B. Okay, that value A plus B value stored in C. Okay, then after you print that value. Next, we perform the subtraction operation, that is the A minus B. Okay, that value after performing operation, that value stored in C. Next, after performing, the C value is displayed. Next, to perform the multiplication operation, okay, that value stored in C. Okay, after performing, that value is displayed by using printf function. Next, division A by B. Okay, that value stored in C. Okay, then you print the C value. Next, A module B. Then that value stored in C. Then to print the C value. For example, here we are reading the A value is 10, B value is 20. Okay, here 10 plus 20. After performing, 10 plus 20 value is 30. That 30 value stored in C. Okay, the C is displayed. Okay, next 10 minus 20. What is the result? Minus 10. Okay, that value displayed. That value stored in C. Then to display that value. Next, 10 into 20. Here 200. Okay, that value stored in C. Then to display the C value. Next, 10 by 20. Here 1, 10. sorry, 1, that value displayed in the C. Next, 10 by 20, 10, that value stored in C to display the, that means 0.5. Okay, that means it displays the 0 only. Next, relational operators. Here, we are performing the relation operation between the two operands. Okay, here relational operators are the binary operators. Here we are using the two operators. These relational operators are used in conditional statements and iterative statements. Okay, the relational operators are less than equal to, greater than equal to, and not equal to. Okay, here we are comparing the two operands. Okay, finally it gives the result is true or false. That means boolean values. Boolean values is zeros and ones. If condition is true, it gives the result is 1. If condition is false, it gives the result is, if condition is true, to give the result is, if condition is true, it gives the result is true. If condition is false, it gives the result is false. Next, it is required to compare the marks of two students, salary 2 persons. We can compare them using relation operator. Here 6.5 less than equal to 25. Okay, 6.5 less than equal to, this condition is true. So it gives the result is true. True means true is nothing but a 1. Here minus 65 greater than 0. Okay, this condition is false. Next, here 10 less than 7 plus 5. Here we follow the operator presidency. Okay, then to perform the operations. Okay, next, relational expressions are used in the decision making statements of a C language, such as a if, while, and for loop statement. Decide the course of action to run. Here relational operators are less than equal to, greater than equal to, and not equal to. Okay, next, a equal 16, b equal to 10. Here 16 less than 10. Okay, this condition is false, so it gives the result is 0. Okay, when condition is false, the result is 0. When condition is true, the result is 1. Okay, next, a less than 16 less than equal to 10. This condition also false, so it gives the result is 0. Next, 16 greater than 10. This condition is true, so it gives the result is 1. So that one value stored in C as usual. Next, a greater than equal to b. 16 greater than equal to 10. This condition is true, so it gives the, it returns the value is 1. Next, a equal to b. 16 equal to 10. This condition is false, so it is, the result is 0. Next, 16 not equal to 10. Okay, so this condition is true, gives the result is 1. Next, by using relation operator, we are writing the one program here. We are going to writing the one program here. First, to declare the variables. First, we declare the 3 variables. That variables are integer type of variables. Okay, so we are taking the input is integer type of input. Here, we reading the AB values. Okay, after performing a less than b, that value is stored in C. Here we taking the one more variable C. Okay, after performing this operation, that that result is stored in C. Here, for example, here I am taking the a value is 10, b value is 20. 10 less than 20. Okay, this condition is true, so use the it means the result is 1. Okay, after performing that operation, that value stored in C, then we print the C value. Here we are checking the one more relation, 10 greater than 20. Okay, this condition is false, so the that value, what is the, when false, the value is 0. Here that value stored in C, then we print the C value. Okay, now C value is 0. Next, a less than equal to b. Here a value is 10, less than equal to, what is the b value? 20. This condition is true. Here, for example, a value is 20, b value is 20. Here we are taking the input values, a value is 20 and b value also 20. Now 20 less than equal to 20. Okay, now this condition is true. Why? Because we are using the operator is less than equal to. This value is less than or equal. When both cases the condition is true. Okay, so it returns the value is 1. Gives the values, it gives the result is 1. Next, we are checking the one more relation. 10 greater than equal to 20. This condition is false, so it gives the result is 0. Next, 10 equal to 20. This condition is also false, so it gives the result is 0. Next, it gives the result is 1. Next, 10 not equal to 20. This condition is true, gives the result is 1. Next one is the logical operator. Okay, they are compared to compare or evaluate logical and relational expressions. Here, logical operators are logical and logical or logical not. Okay, logical and represented double ampersand. Logical not represented type symbols. Next, logical not represented with explanation mark. Okay, here, for example, we are taking the one example. Here, taking the one example. If both the expressions are true, the result is true. Here, logical and when both the expressions are true, the result is true. Remaining all times, the result is false. Okay. In logical or any one condition is true, the result is true. Remaining the both conditions are false, the result is false. Okay, when both conditions are false, the result is false. Remaining all times the result is 1. We are writing the one truth table. Okay, A, B, A and B. Here, true, the result is true. A is true, false, the result is false. False, true, the result is false. Next, false, the result is false. Okay. In A, B, A or B, A is true, B is true, the result is true. A is false, A is true, B is false, the result is true. A is false, B is true, the result is true. When both are false, the result is false. Remaining all times, the result is true. Here, when both are true, the result is true. Remaining all times, the result is false. Here, if any one of the two expressions is true, the result is if any one the two expressions is true. Example, a less than m or a less than n. Here, I am taking the one value a greater than b and x equal to y. Here, a value is 10, b value is 20, x value is 10, y value is 10. Here, what is the value? 10. 10 greater than 20 and 10 equal to 10. Okay, this condition is false. This condition is true. Finally, the result is false. For example, here I am taking the a value is 30, b value is 20. Here x value is 10, y value is 10. Now, what is the value? 3. 30. 30 greater than 20, the condition is true. 10 equal to 10, the condition is true. When both conditions are true, the result is true. Okay. Next one is the logical OR. Here I am taking I'm giving the one more example, that is the logical OR. Logical OR. Here, what is the A value? A value 10, M value 20, A value next N value is 5. Here that value is implemented in these conditions. 10 less than 20 or 10 less than 5. Okay, this condition is true, this condition is false. Finally, the result is true. Okay, any one condition is true, the result is true. Remaining, when both are false, the result is false. Remaining all times, the condition is true. Next one is the logical not operator. It evaluates the true if the expression is false, and evaluates to false if the expression is true. Here, A equal to 14, B equal to, here we are taking one example, A equal to 14, B equal to 15, C equal to 13. Okay, A value, what is the A value? 14. Okay, 14 greater than 15, and next 14 greater than 13. Here, this condition is false, this condition is true. Finally, the result is false. When false, it returns the value is 0. False is nothing but the value is 0. True is nothing but the value is 1. Next one is what is the value? 14 greater than 15, or next 14 greater than 13. Okay, this condition is false, this condition is true, the result is true. True is nothing but it returns the value is 1. 2 is nothing but 1. Next, here we are writing the one code. Here we are taking the two input values, AB values. Okay. Next, here for example, A value is 0, B value is 1. Okay, 0 and 1. So the result is 0. Next, 0 or 1. The result is 1. Next, 1 not equal to 0 means the result is 1. Okay, this is an example for logical operators. Next one is the assignment operators. Assignment operators evaluate the expression on right of the expression and substitute it to the value or variable on the left of the expression. Here, this is our expression. The value substituted in the left side expression. Okay, assignment operator is to assign the value to the operand. Okay. In addition, C has a set of shorthand assignment operators of the form. That is, the syntax is variable operator equal to expression. For example, A plus equal to 10 is nothing but this is the shorthand operators. What is the meaning here? A equal to A plus 10. Same as x plus equal to 1 is the same as x equal to x plus 1. The commonly used shorthand assignment operators are follows. Here, statement with simple assignment operators A equal to A plus 1. The common value A plus equal to 1. A equal to A minus 1. The common value A minus equal to 1. A equal to A into n plus 1. The common A into equal to n plus 1. Next, A equal to A by n plus 1. This is the common shorthand operator. A division equal to n plus 1. Next, A equal to A module B. Here the common shorthand operator A module B equal to B. Here we are writing the one sample program by using assignment operators. Here this is the shorthand assignment operator. Here first to declare the integer variables. Okay. Next, after declaring, to read that values. Here we are reading the AB values from keyboard. Next, C equal to A plus equal to B to evaluate this expression. Here I am taking the input 10, B value is 20. A value is 10, B value is 20. Here C equal to evaluate this expression, A plus equal to B, meaning A equal to A plus B. What is the A value? 10. 10 plus 20, 30. That value stored in A. Next, that value assigned to the C. Okay. A value is 30. Finally, that value assigned to the C. Same like that R. Okay. Next, increment and decrement operators. For suppose if you want to increase the one value, if you want to decrease the one value by using increment and decrement operators, here increment is nothing but to increase the one value. Decrement is nothing but to decrease the one value. Here, they are extensively used in for and while loops. Okay. Next, here increment decrement operator, that is the prefix operators and postfix. Prefix operator is nothing but a operator used before the operand. For example, A plus plus A. This is the prefix. Next, A plus plus. This is the postfix. Okay. First to assign the value, first to increment, then to assign the value to the left side operator. Okay. Prefix and postfix. Variable name here plus plus. Hey, that is the plus plus is the operator. A is the variable name. Next, A plus plus. Variable name is the A, plus plus is the operator. Next, consider the following. Here, M equal to 5. Pi equal to plus plus M. Prefix. We are using the prefix. First to increase the value. Then, after increation, plus 1 plus 1. 1 plus 5. That value is 6. That value is assigned to the Y. In this case, the value of Y and M would be 6. Suppose if you rewrite the above statement as M equal to 5. Next, what is the 5? 5 value. M value, what is the M value? 5. That value assigned to the Y. Then the value of Y will be 5. And then of M will be 6. After compilation, that value is increased. Okay. Prefix means first to increase, then assign to the value. Okay. Okay. Here we are taking one example. Okay. First, ABC to declare the variables. After declaring the variables, to read the two input values, A and B value. Here, first assign, then incremented. After compilation, that value is incremented. After compilation, the A value is become a, for example, A value is 5. After compilation, that A value become a 6. Before, then 5 value assigned to the C. 5 value is assigned to the C. After compilation, the A value become a 6. Next printf. Here, see, first to increase the A value. Okay. What is the before A value? 6. Now the A value is increased 7. That 7 is assigned to the C. Now A value is 7 and C value is 7. Here, to decrement, first, what is the A value now? A value is 7. Okay, the 7 assigned to the C. Then after compilation, the A value become a 6. Next, here, first to decrement the value, what is the A value? Last 6. So after decrementation, that A value is become a 5. That value assigned to the C. Then after, the A value is 5. Okay. This is increment and decrement operators. Next one is the conditional operators. Okay, conditional operators we also call as the ternary operator. Ternary operator is nothing but here we are using the 3 operands. Okay. For example, expression 1 question mark, expression 2 colon, expression 3. Here we are using the 3 operands. Expression 1 is the operand. Expression 2 second operand. Expression 3 is the third operand. Here the ternary operators works as a expression is expression 1 is evaluated first. If expression 1 is true, to evaluate the expression 2. If expression 1 is false, to evaluate the expression 3. It is working like a if else condition. First, to evaluate the expression 1, if condition is true, if expression 1 is true, then to evaluate the expression 2. If expression 1 is false, to evaluate the expression 3. Here we are taking one example. A equal to 10, B equal to 15, 10 greater than 15. Okay, this condition is false. So to evaluate the expression 3. Here this is the expression 1, expression 2, expression 3. First, to evaluate the expression 1, if expression 1 is true, to evaluate the expression 2. If expression 1 is false, to evaluate the expression 3. Here, after final, here we are taking the syntax variable. First, expression 1, expression 2, expression 3. If expression 1 is true, to evaluate the expression 2. If expression 1 is false, to evaluate the expression 3. Okay. Finally, that value is stored in variable. Here, we are declaring the ABC values. After declaring, to read that values. After reading, here, for example, A value is 10, B value is 20, 10 greater than 20. Condition false. So, to print the expression 3. What is our expression 3? Percentage D is big. B value is 20. Next one is the bitwise operators. Here, bitwise operators, it perform the bits operations. Given data is converted into the bits. Okay. Here we are performing the bits. We are performing the bits operations. C has the two categories of bitwise operator. That operators are data and bit level. Logical bitwise operators and shift bitwise operators. Okay. Here, logical bitwise operators. Bitwise and bitwise are bitwise exclusive are shift left, shift right, and one's complement. Okay. Next, here 0 0, the result is 0. R is the result also 0. A exclusive are also 0. Next, one's complement. If 0 is, the result is 1. 1 is, the result is 0. Next 0 1 R 0 true. Next true. Next true. Next 1 0 1 0. The result is 0. Already we discussed in logical operator. Next 1 0 by implementing R operator. The result is 1. Here exclusive R. The result is 1. Here what is the value? 1. Trial 1 means the result is 0. Next, when both are true, the result is true. The result is true. Exclusive R, the result is false, and once complement, the result is 0. Next, bitwise shift operator. The shift operator moves the bits right or left. The bitwise shift right is a binary operator that requires the first operator is the value to be shifted. The second operator specifies the number of bits shifted. Here, A greater than 50. Here we are moving the right side. Shift. We are moving the shift right side. The remaining the values are filled with zeros. Next, bitwise left shift. When we shift the binary numbers, the left shift operator multiply by the power of 2. If we shift binary number 2 places to the left, we are multiplying by 4. If we shift the 3 places, we are multiplying by 8. Next, this is the example for bitwise operators. Next, special operators. And special operators are the comma operators and size of operators. The comma operators is separated by the variables and expressions also. This is the example. For example, the statement x equal to 10 comma y equal to 5 comma x plus y. Next, this is one more example. N equal to 1 comma m equal to 10, n less than equal to m. This is the one expression. N plus plus comma m plus plus. If we in while loop, while c get char comma c not equal to 10, next exchange the value t equal to x comma x equal to y, I equal to t. Next special operator, that is the size of operator. Size of operator to calculate the byte size. To calculate the type of byte size by using size operator. Here size of sum, it is to calculate the sum size. Sum size. Next long int size. Next size of 235. This is example. Thank you.